82%. That is the number the United States government quietly published this week, and the moment it went out, almost every outlet that picked it up called it a weather story. A wet winter somewhere, a dry one somewhere else. Filed it away, moved on. I want to be as direct with you as I know how to be right now. This is not a weather story. It is a food story. And the world has not noticed because the last time the Pacific Ocean lined itself up the exact way it is lining up now, the year was 1877, and 50 million people died. Not because one harvest failed somewhere, because the harvest failed everywhere at once. Same season, same signal, different continents, same catastrophe. So the question this video is built around is not whether something is coming, it is whether the modern world quietly constructed its entire food supply on top of an assumption the Pacific is now getting ready to break.
If a number that sounds like background noise can carry a history like that, you will want to stay for all of it. Hit like and subscribe to the channel because we are tracking this ocean all summer long. And tell me in the comments which country you are watching from and whether the price of food where you are has already started to move. Part 1. The Pacific just changed its mind. Most people heard the words El Niño watch this week and did with them what most of us do with weather forecasts. Filed them somewhere in the back of the mind. Probably means a wet winter in one place, dry in another, and then got on with the day. What was actually announced is one of those rare moments where the official language genuinely undersells what is happening underneath it. On the 14th of May 2026, the Climate Prediction Center, the arm of the American government that watches the tropical Pacific for a living, issued a formal El Niño watch. That phrase has a specific technical meaning. It means the conditions that produce an El Niño are expected to develop, and they want everyone whose livelihood depends on the forecast to start paying attention now. The numbers attached were not vague. The agency put the probability of El Niño conditions forming during the May through July window at 82%, and it put the probability of those conditions still holding through the heart of winter, December 2026 through February 2027, at 96%. Read those two numbers one more time, because they are doing quiet but important work. 82% that it arrives within weeks, 96% that once it arrives, it stays. This is not a maybe. This is a forecast leaning hard in one direction, and the people issuing it do not lean unless the ocean is telling them to. Here is what makes it stranger. As of mid-May, the ocean and the atmosphere were still officially classified as ENSO neutral. Not El Niño, not La Niña, the in-between. The system is standing on the doorstep with its hand on the handle. It has not walked through yet. The most recent weekly temperature reading from the key stretch of equatorial Pacific that forecasters watch was running roughly 0.4 degrees Celsius above normal. Still inside the neutral band, has not crossed the official line. But the direction is not ambiguous. The Pacific spent more than a year in a cool La Niña-leaning mood. Now, for the first time in over a year, it has turned. When the Pacific changes its mind, the rest of the planet eventually has to go along with it. Before we go further, a small piece of bookkeeping, because if I skip it, a number you might see elsewhere will not match what I am telling you, and I do not want you confused. For decades, the main tool scientists used to officially call an El Niño was something called the Oceanic Niño Index. Think of it as a thermometer hung off the side of the Pacific. When it read warm enough for long enough, El Niño. When it read cool enough, La Niña. Simple, reliable, the standard for a generation. But a problem had been building inside that measurement. The entire ocean has been warming. Year after year, the background temperature of the whole Pacific has been creeping up, which meant the old El Niño threshold was getting easier and easier to cross. Not because the El Niño signal itself was getting stronger, but because the water it was being measured against was already warmer to start with. Picture trying to measure the height of a tide by marking the waterline on a dock, while the dock is slowly sinking into the seabed. After a while, your measurements stop telling you about the tide. They start telling you about the dock. So in February of 2026, the Climate Prediction Centre retired the old index and replaced it with something called the Relative Oceanic Niño Index. The new tool subtracts out the planet-wide warming trend. What is left is the El Niño signal itself, clean, separated from the warmth it has been riding on top of. That is why you will hear the El Niño described carefully right now in terms of watches and probabilities, rather than a single number that just flipped. It is partly because the way it is officially measured changed 3 months ago. But the underlying physical truth has not changed at all. The equatorial Pacific has turned warm. The cool stretch is over. Now here is where it gets genuinely interesting, because the surface of the ocean is only half the picture. Frankly, it is the less important half. The real signal, the one forecasters are actually leaning on, is happening underneath. Out of sight, below the waves. The Climate Prediction Centre reported that the index measuring subsurface temperatures in the equatorial Pacific has now risen for 5 consecutive months. 5 months in a row of warming in water you cannot see from the surface. And the engine driving that is something with a wonderful name, a downwelling Kelvin wave. Picture a slow, enormous pulse of warm water travelling from west to east along the equator, but moving beneath the surface rather than on top of it. A swell travelling under a blanket. You cannot see it, but it is there, sliding eastward somewhere between 100 and 250 meters down. And the water inside that pulse is running 6 to 7 degrees Celsius above normal. That is not a nudge. That is a freight train of heat moving toward the eastern Pacific, just below the line of sight. Multiple independent analyses have looked at the size of that subsurface heat and compared it to the great El Niño events of the modern record. The comparison they keep landing on is unsettling. The heat staged in the ocean right now is in the same class as the onset phases of 1997 and 2015. Those 2 years produced the 2 strongest El Niño events ever recorded. The fuel that drove them is the kind of fuel sitting in the Pacific today. So if the heat is loaded, why is this still only a watch? Because an El Niño is not just warm water, it is a partnership. The ocean and the winds have to start working together, reinforcing each other in a feedback loop. Normally, trade winds blow across the tropical Pacific from east to west, piling warm water up on the western side. For a full El Niño to lock in, those winds have to slacken. As they slacken, the warm water slushes back east. That warmth weakens the winds further. Weaker winds let more warm water through, and around it goes, each step amplifying the next. That is called coupling. The ocean speaks, the atmosphere answers, and they escalate together. As of mid-May, the ocean has spoken loudly. The atmosphere has only partly answered. The coupling has not fully taken hold yet. Until it does, the system stays on the doorstep. El Niño is not a one-off event that appears from nowhere. It is one phase of a cycle, a slow oscillation the tropical Pacific has been running for as far back as we can reconstruct. 3 states: La Niña, the cool phase, when trade winds blow strong and warm water piles against the western Pacific. Neutral, the in-between, where we technically still sit. And El Niño, the warm phase, when the winds slacken and the warmth floods east. What makes right now significant is not just that El Niño is coming. It is that the Pacific has spent an unusually long, sustained stretch on the cool side of that cycle and is now swinging hard the other way. A long cool phase followed by a sharp swing to warm. That is a pattern with history. And as you will see when we get to 1877,
It is a pattern worth paying very close attention to. Part 2. How strong and why it matters. There is a temptation when looking at an El Niño forecast to treat strength as a dial. A little more, a little less. As if the difference between a weak event and a strong one is just volume. Turn it up, turn it down. That idea is wrong. The wrongness of it is the whole reason this video exists. The difference between a normal El Niño and a super El Niño is not loud versus louder. It is a regional weather pattern versus a planetary one. A difference of kind, not degree. And the 2026 forecast is sitting right on the fault line between the two. The Climate Prediction Centre's mid-May assessment put the odds of this event peaking at strong or very strong at roughly 2 in 3. Within that, the odds of a true super El Niño, defined by a temperature anomaly of 2 degrees Celsius or more in the key Pacific region, came in at roughly 1 in 3. 1 in 3 for a super event. And that figure had climbed from roughly 1 in 4 just a month earlier. The odds of a monster are not holding steady. They are rising. The European Centre for Medium-Range Weather Forecasts, which has been the most aggressive of the major forecasting systems, ran an ensemble at the start of May where roughly half its members exceeded 2.5 degrees above normal by October. Its individual members for September ranged from about 1.7 to about 3.3 degrees above normal. The average of those members pointed towards something close to 3 degrees by late 2026. 3 degrees above normal would place this El Niño in the same conversation as the strongest events ever recorded. Not a strong El Niño. One of the strongest, full stop. The World Meteorological Organization, which blends models from many countries, had its multi-model average approaching a 0.5 degree by midsummer with what it described as a near unanimous upward trajectory. Different systems, different methods, same direction. Up. It is worth slowing on what the threshold numbers actually mean, because the categories are not arbitrary and the gap between them is where the danger lives. Forecasters call an event weak when the peak anomaly lands around 0.5 degree to 1 degree above normal. Moderate runs from about 1 to 1.5. Strong runs from about 1.5 to 2. Very strong, or super, is the tier above 2 degrees. The 1997 to 1998 event peaked above 2.5 degrees. 2015 to 2016 reached the same neighborhood. Those are the reference monsters, the events people in the field still measure others against. Now you have a 2026 forecast where the most likely outcomes sit in the strong to very strong band, with a real and rising possibility reaching into the territory of the worst events in the modern record. But I have to stop here and be completely honest with you, because if I do not, you will go online after this and see claims that do not match anything I just said. There is content circulating right now claiming things like 100% certainty of a super El Niño, all models in perfect unanimous agreement, a guaranteed record-shattering event. That is not what NOAA says. That is not what the European Centre says. That is not what the World Meteorological Organization says. The European Centre's own public communications state plainly that there is strong consensus that an El Niño will develop, but there is no unanimity that a high-intensity outcome is certain, and the spread between its own ensemble members means a precise peak value cannot be reliably given. The honest version of this forecast is not 100% anything. It is this. A strong and possibly record-breaking El Niño is likely, peaking around the turn of the year, but the atmosphere has not locked in yet, and certainty is not on the table. And that brings me to the single most important caveat in this entire video, the one you need to carry with you through everything that follows. Forecasters call it the spring predictability barrier. In the boreal spring, exactly where we are now, El Niño forecasts have historically lower skill than forecasts issued later in the year. There is a physical reason. The coupling between the ocean and the atmosphere temporarily weakens in late spring, which makes the whole system harder to model and harder to predict. The history is humbling. In 2014, spring model output pointed clearly at a strong El Niño. It never fully developed. In 2017, the same thing. Spring forecasts leaned strong, and the event fizzled. So when I tell you the odds of a super El Niño are 1 in 3 and climbing, I am also telling you that spring forecasts have been confidently wrong before. A careful person holds both of those facts at once. This is a serious forecast. It is not a sure thing. Both of those statements are true simultaneously, and this channel is going to hold both all the way through. Part 3. 1877. I want to tell you about a year, and I want you to hold the human scale of it, because the rest of this video depends on you feeling the weight of it, not just hearing the number. The year is 1877. The event stretched from 1876 into 1878. Historians call it the Great Drought, the global famine. The death toll, not from folklore, but from peer-reviewed climate science published in a major journal, is estimated at more than 50 million people. 50 million. That is not a regional tragedy. That is a number on the scale of the deadliest events in all of human history. Most people watching this have never heard of it. That obscurity is itself part of the story. We remember the wars of the 19th century, we remember the named disasters, but the Great Drought, an event that killed on the scale of the largest catastrophes humanity has ever recorded, sits almost entirely outside public memory. Part of that is because it happened in places the dominant history paid less attention to. Part of it is because famine, unlike war, has no single dramatic moment. No battle, no date. Just a slow, grinding, distributed dying across continents. Whatever the reason, the result is that the single best real-world demonstration of what a super El Niño can do to the human food supply is also one of the least known. We are walking toward a forecast with the most relevant page of the manual already torn out. Let me take you through where those deaths happened, because the geography is the entire point. In India, what became known as the Great Famine of 1876 to 1878 tore through the south and centre of the country, centred on the regions around Madras, Bombay, Mysore and Hyderabad. The death toll there, depending on which careful estimate you use, runs somewhere between 5.5 million and 10 million people. In northern China, in the same window, a famine so severe that the people who survived it called it the Incredible Famine, because the scale of it was beyond what they had words for. It struck the provinces of Shaanxi, Henan, Shandong, Shanxi, and Zhili. Estimated deaths, 9 to 13 million. In northeastern Brazil, in a catastrophe Brazilians still call the Grande Seca, the Great Drought, roughly 2 million people died, with the state of Ceará all but destroyed. And it did not stop there. Drought and famine struck Ethiopia, Sudan, Egypt, Korea, Vietnam, the Philippines, Java, parts of southern Africa, Morocco. Pull back far enough, and you are not looking at a list of separate national disasters. You are looking at a single thing. A planet where the rains failed almost everywhere that mattered, all at once. That is the detail to lock onto, because it is the hinge of this entire video. The horror of 1877 was not the severity of any one drought. India had suffered terrible droughts before, so had China, so had Brazil. What was new What was almost unimaginable was the synchrony. The monsoon failed across multiple continents in the same window of time. The breadbaskets of the world did not take turns failing. They failed together. And I want to say this plainly, because it is the sentence the whole video is built around. The simultaneous failure of agriculture across continents is the thing the modern food system is not built to survive. A normal famine, however terrible, has a geography. It has an edge. The drought ends somewhere, and on the other side of that edge, there is a region having an ordinary year. Grain can move toward the hunger. The entire human response to famine, for as long as there has been trade, has depended on that edge existing. You carry food from the place that has it to the place that does not. In 1877, there was no edge. When the monsoon fails in India, in China, and in Brazil, all in the same season, there is no neighbour with a surplus to move. There is no other side. The whole planet is the inside of the famine at once. Synchrony does not just add the regional disasters together. It removes the thing that has always been used to survive them. The timing made it worse in a way that is almost too neat to be real. The 19th century was the exact period when the world's food markets were being stitched together for the first time, by railways, steamships, and the telegraph. The promise of that integration was resilience. A connected market could always route food from surplus to shortage. The reality when 1877 hit was the opposite. A connected market with no surplus anywhere does not route food. It routes the shortage. It transmits the failure outward instead of absorbing it. 1877 was the first stress test of a globalized food system. The system did not pass. There is a second layer to this story, and I have to handle it carefully because it is important and also contested. In 2001, the historian Mike Davis published a book called Late Victorian Holocausts, and it remains the definitive popular account of these famines. Davis argued that the drought was the trigger, the physical cause, the thing that made the crops fail. But the mass death, he argued, was not made by the weather alone. It was amplified by policy, by the economic ideology of the colonial powers that governed many of the affected regions. He documented grain being exported from famine zones, even as the people who grew it starved. India continued shipping wheat to Britain through the worst of it. He documented railways, the great modern marvel of the age, being used to move grain toward ports for export rather than inland to the hungry. The climate science of 1877 is settled, the part about the ocean and the drought. Davis's argument about colonial governance turning drought into catastrophe of this magnitude is serious and influential, and also debated among economic historians. It is an interpretation. So when this video talks about 1877, keep that split clear. The climate trigger is established fact. The policy amplification is Davis's argument. But I do not want to wave past Davis's point too quickly, because even in its contested form, it carries a lesson that travels directly to 2026. The drought sets the upper bound of the disaster. The human response decides where within that bound the disaster actually lands. A drought of a given severity can produce a hard year or a mass casualty event. The difference is not written in the rainfall, it is written in decisions. That is the part that should follow us forward. Part 4. The triple whammy. For over 100 years, the famines of 1877 sat in history books as separate entries. The Indian famine in one chapter, the Chinese famine in another, the Brazilian drought somewhere else entirely. Each one studied on its own terms. The idea that they were a single, physically linked event was not on the table, because no one had assembled the evidence to put it there. Then in 2018, a paper was published in the Journal of Climate. Title: Climate and the Global Famine of 1876–78. The authors were a team of climate scientists and one historian, Mike Davis.
The same Mike Davis from late Victorian holocausts. He was a co-author on a hard climate science paper, History and Physics working the same problem in the same study. That does not happen often. The team brought together every line of available evidence, direct observations from the period, paleoclimate reconstructions, tree ring records reaching back centuries before instruments existed, and climate model simulations to test whether the physical story held. They set all of it against roughly 140 years of instrumental data and an 800-year tree ring drought record. What they found: the Great Drought was not a coincidence. It was produced by an extraordinary, possibly unique combination of three simultaneous ocean conditions. The team's own framing, and the one I will use, is the triple whammy. Here is the first part. A record-breaking El Niño in the tropical Pacific, the same phenomenon we have been discussing, and here is the detail that should make something inside you sit up straight, given where we are in 2026. That 1877 El Niño was likely primed, made more explosive, by a preceding stretch of cool, La Niña-like conditions in the years before it. The Pacific went cool, then it went violently warm. That El Niño was the engine that drove the core droughts across what scientists call monsoon Asia, the vast stretch of continent whose agriculture lives and dies by the seasonal monsoon rains. Here is the second part, an extreme positive phase of the Indian Ocean dipole. The Indian Ocean is a temperature seesaw, describing the difference in sea surface temperature between its western and eastern sides. When it tips hard into its positive phase, it rearranges where rain falls across the entire Indian Ocean region. In 1877, the study found that seesaw tipped harder than at any other point in the entire record, before or since. The strongest positive Indian Ocean dipole ever documented. It intensified and prolonged the drought across Australia and deepened the disaster across Asia. Here is the third part, a record warm North Atlantic. On the other side of the planet, the North Atlantic Ocean in 1877 was the warmest it had been in records stretching back to the 1850s. That warmth pushed the moisture-bearing winds that would normally carry rain to northeastern Brazil northward, away from where they were needed, and extended drought into northern and southeastern Africa. Three oceans, three simultaneous record or near-record conditions: the Pacific, the Indian, the Atlantic, all pulling in the same catastrophic direction at the same moment. The headline finding of that study is the sentence to carry with you. According to the 800-year paleoclimate reconstruction, monsoon Asia in 1877 experienced the single most intense drought of the last 800 years. Not the worst in living memory, not the worst in the instrument record. The worst on that measure in 8 centuries. There is also a piece of physics worth making explicit, because it is what makes the triple whammy more than 3 bad rolls of the dice landing together. The Pacific El Niño was suppressing the monsoon over Asia. The extreme Indian Ocean dipole was independently doing its own damage to rainfall patterns over the same broad region. They were not just adding their droughts together side by side. They were stacking in the same places, deepening each other's reach. And the warm North Atlantic was pulling moisture away from a third continent entirely. Not 3 regional famines that happened to coincide, a single planet-scale rearrangement of where rain was allowed to fall, driven by 3 oceans all in an extreme state at once. The lead author of that study, Deepti Singh, said something about the work that is the most important sentence in this entire video. She said the study showed that the stage was set for a reprise of the worst known drought and famine. Not a prediction, not a guarantee, but that the configuration which caused 1877 is not some impossible vanished thing. It is a physically possible state. The climate system can re-enter it. The stage, she said,
is set. And here is the bridge back to now, because once you know it was a mechanism and not an accident, you are forced to ask the only question that matters. 2 of the 3 ingredients of that configuration are not hypothetical for 2026. A developing El Niño emerging out of a long La Niña leaning cool stretch. That is the same opening move as 1877. And, as you will see shortly, the background ocean warmth, the 3rd ingredient, is broadly already present. The machine's parts are on the table. Part 5. The assumption underneath everything. Let me state the core of this video as plainly as I can in 1 sentence. Then I will spend the rest of this part proving it. The global food system is built on a hidden assumption, and that assumption is wrong. The assumption is independence. The quiet, unspoken belief that a bad harvest in the United States, a bad harvest in India, a bad harvest in Australia, and a bad harvest in Brazil are unrelated events. That each one is its own roll of the dice. That when the wheat fails in Kansas, that tells you nothing about what the rice is doing in India or what the wheat is doing in Australia. Each breadbasket in this picture is a separate gambler at a separate table, and the house assumes their luck does not correlate. This assumption is not just a vague cultural belief, it is structural. It is load-bearing. Crop insurance is priced on it, because if breadbaskets failed together, the insurers could not cover the losses, so the math quietly assumes they do not. National grain reserves are sized on it, because a country only needs to stockpile enough to bridge its own bad year, on the assumption it can always buy from someone else having a good one. International trade models lean on it, the entire architecture of global food security, the buffers, the reserves, the trade flows, the insurance, is built on the belief that the world's breadbaskets roll their dice separately. In 2019, a study published in the journal Science Advances took that assumption and broke it. The researchers tested 4 of the major recurring climate patterns that move weather around the planet: El Niño and the Southern Oscillation, the Indian Ocean Dipole, tropical Atlantic variability, and the North Atlantic Oscillation. 4 candidates, 4 forces that could, in principle, link harvests across the globe. Only one of them can force globally synchronous crop failure. Only one can reach across the entire planet and pull the breadbaskets down together. That one is El Niño. The others are real. The Indian Ocean shapes harvests around the Indian Ocean. Tropical Atlantic variability shapes them around the Atlantic. The North Atlantic Oscillation pushes European and North American weather around. That each of those is regional. Each has a footprint, and the footprint, however large, has edges. El Niño has no edges. Not at full strength. El Niño is the only one of the 4 that operates at the scale the global food system actually trades at. So when you ask whether there is a single force that can override the independence of the world's breadbaskets, the honest scientific answer is not a vague maybe, it is a specific name. And the name is El Niño. The study found that El Niño accounts for roughly 18% of the year-to-year variability in globally aggregated maize production. 18% of the swing in the entire planet's corn harvest, traceable to one ocean pattern. For wheat, the figure was around 7%, for soybean around 6%. But the numbers are not even the most important part. The most important part is a single sentence from the paper itself. The researchers wrote that their finding runs counter to a central pillar of the global agriculture system, a pillar that assumes crop failures in geographically distant breadbasket regions such as the United States, China, and Argentina are unrelated. A central pillar. That is the language the scientists themselves used, not a minor assumption, a central pillar. And El Niño is the force that knocks it down. A companion study by the same core team traced the mechanism. Most of El Niño's effects on the world's crops trace back to a single large atmospheric circulation pattern. One pattern. It develops in the late summer, strengthens, and persists through the following spring. While it persists, it touches the climate on continents in all 4 corners of the Pacific Basin at once. Picture one hand resting on a console of levers. When that hand pushes down, 4 levers move together, because they are connected to the same hand. That is the mechanism. One trans-Pacific circulation pattern, 4 corners of an ocean, harvests rising and falling together because they are wired to the same switch. That same study estimated that El Niño accounts for something like 57% of the variability in wheat yields across North and South America combined. More than half the swing in the wheat harvest of 2 entire continents traceable to that one pattern. And a separate study from 2020 found that when the jet stream locks into large, slow, stationary meanders, what scientists call amplified Rossby waves, the probability of simultaneous heat extremes hitting linked breadbasket regions rises by a factor of up to 20. 20 times more likely that the heat hits them together. A follow-up by the same researchers, published in 2023, found something that should stop you completely. The climate and crop models we rely on, the ones that inform government planning and market forecasting, do reproduce these jet stream wave patterns reasonably well. But they underestimate the surface damage. They underestimate how badly the crops actually respond. In other words, the official projections are not alarmist. If anything, they are the opposite. They underwarn. The real risk of synchronized failure sits wider on the bad side than the published numbers show. The danger here is not that the warnings are too loud. It is that the warnings, by the science's own admission, are too quiet. 3 separate research efforts, 3 different methods, all converging on the same conclusion. El Niño is the one force that can synchronize failure. The models underestimate how bad that synchronization gets, and the synchronized risk is climbing. 3 teams, 3 methods, 1 direction. Part 6. Winners, losers, and the cushion that might not hold. El Niño is not a blanket. It does not settle over the planet and make every harvest everywhere fail. That is not how it works. El Niño does something more surgical, and in a way more dangerous. It makes a specific map of harvests fail and leaves others alone. Sometimes it even helps a few. The danger is not universal ruin. The danger is the shape of the map. Start with the one piece of relatively good news, because it matters later. Soybean. Under El Niño, soybean is the consistent winner. Global average yield tends to improve by roughly 2 to 5%. El Niño conditions tend to favour the major soybean growing belts of the United States and South America. Soybean comes out ahead. And now the rest: maize, rice, and wheat. Under El Niño, these 3 fare worse. The global average yield change for them lands somewhere in the range of -4.3 to a slight positive. Maize and rice generally take a hit. The global average effect is, frankly, modest. If you looked only at that number, you might shrug. That is exactly the trap. The global average is the wrong thing to look at. The danger of El Niño is not in the average. The danger is in the correlation structure, in who fails together. Here is the loss map. Under El Niño, the regions that take the damage are India and Southeast Asia, where rice and wheat suffer as the monsoon weakens. Australia, where the wheat belt dries out. Northern China, where maize and wheat are hit. The Brazilian Cerrado and the Brazilian Northeast. And Southern Africa, where the maize crop, the staple that feeds the region, comes under pressure. Look at those names: India, China, Australia, Brazil, Southern Africa. These are not minor agricultural players. These are major exporters and major populations. And in the case of India and Southeast Asia, the largest rice-consuming populations on the planet. The loss map
is really a monsoon map. It is the map of the agricultural regions whose entire growing calendar is built around rains that El Niño is known to suppress. That is why the same names keep appearing. They are not unlucky. They are physically wired to the part of the system El Niño disrupts most directly. Rice alone is the staple food for more than half the human population. The overwhelming majority of the world's rice is grown and eaten in exactly the monsoon-dependent regions that sit on the El Niño loss map. You are not looking at an abstract chart of production statistics. You are looking at the calorie supply for the largest concentrations of people on the planet, all of it wired to the same monsoon, and the monsoon wired to the same Pacific. Now look at who wins. The winner map under El Niño is essentially two regions, the United States Midwest and southeastern South America, Argentina and southern Brazil, for maize and soybean. That is the cushion. That is the buffer. When El Niño pulls the loss map regions down, the system's quiet expectation is that the United States and Argentina will be having a good year, producing a surplus, and that surplus flows out into the world and catches the countries that are short. That is how the independence assumption is supposed to save us even when it is being violated. Some fail, some win. Winners cover losers. The system holds. Now hold that loss map next to the triple whammy of 1877. A super El Niño on the 1877 pattern strikes India, China, Australia, the Brazilian Cerrado, and southern Africa at the same time on the same signal. Multiple major exporters, the world's largest rice consumers, all pulled down together in the same growing season. That is not a hypothetical. That is the loss map and the 1877 pattern describing the same set of countries. So everything comes down to the cushion. It comes down to whether the United States and Argentina hold. And here is the uncomfortable truth. The science says those regions tend to win under El Niño. But tend to is not the same as always. A tendency is a statistical lean, not a guarantee. There is no law that says the United States Midwest must have a good year just because the Pacific is warm. So the genuinely frightening scenario is not the one where El Niño hurts everyone. It is narrower and sharper than that. It is the scenario where El Niño hurts all the usual losers, exactly as the 1877 pattern predicts. And at the same time, for reasons of its own, the usual winner has an off year. The cushion fails to inflate. The surplus that is supposed to catch the world simply is not there. The losers lose, and the catcher drops the catch. The cushion is not the whole world. It is essentially two regions, the United States Midwest and southeastern South America. That is it. The entire structure that is supposed to absorb a synchronized El Niño shock to the loss map rests on two parts of two continents having a good year at the same time. And those two regions are subject to their own weather, their own droughts, their own bad luck, none of which is bound by what El Niño does. The system is not asking for a miracle. It is quietly assuming that the two specific places it depends on will not have an off year in the 1 year it most needs them not to. Most years that assumption is fine. The danger is that it only has to be wrong once, in the wrong year. Part 7. The system is already bleeding. Here is the thing I keep coming back to, the thing that turns this from an interesting piece of climate history into something with genuine teeth. A strong El Niño in 2026 is not going to arrive onto a healthy, well-buffered, well-fed global food system. It is going to arrive onto a system that, in several of its most important regions, is already bleeding before the first cut. Start with the United States, that cushion the whole world quietly depends on. As of late April 2026, the American winter wheat crop was in trouble. The share of the crop rated good to excellent had fallen to roughly 30%. A year earlier, that same figure had been somewhere around 45 to 48%. The crop went into this spring rated dramatically worse than it was rated the spring before.
Drought covered roughly 69% of the United States winter wheat growing area. More than 95% of the southern plains, the heart of American hard red winter wheat country, was in drought or abnormal dryness. In Oklahoma, 54% of the wheat was rated poor or very poor. In Texas, 51. In Colorado, 49. When the USDA put out its May 2026 supply and demand estimates, it forecast winter wheat production down 25% from the year before. A quarter of the crop gone. The cushion is already compromised. The region the world counts on to produce a surplus when El Niño pulls the other breadbaskets down is itself walking into this event with a drought-hit wheat crop. And it is not just the United States. Global wheat production for 2026 is estimated at around 819 million tons. The year before, the world had produced a record of around 844 million tons.
Global wheat production is forecast to fall from a record high. United States wheat ending stocks, the amount left in the bin at the end of the marketing year, were projected to come in around 18% below the prior year, and global corn ending stocks were projected at their lowest level since the 2013 to 2014 marketing year. The world's pantry for two of its most important staple grains is being drawn down at exactly the moment the one force that can synchronize crop failure is forecast to switch on. Ending stocks are the grain left over at the end of a marketing year, the carryover, the cushion between one harvest and the next. If the world goes into a bad year with full bins, the carryover absorbs the shock. Prices stay relatively stable. The system rides it out. If the world goes into a bad year with thin bins, there is nothing to absorb the shock. A yield shortfall translates almost immediately into scarcity and price. The cushion right now is thin. Now go to the loss map and check the regions on it. India. The India Meteorological Department issued its 2026 monsoon forecast, calling for the monsoon to come in at roughly 92% of the long period average. In the language of monsoon forecasting, that is below normal. It would be India's first below normal monsoon in 3 years. The reason the department gave for the downgrade was specifically the developing El Niño. Indonesia. The Indonesian Meteorological Agency forecast that the 2026 dry season would arrive earlier than the 30-year norm and run drier. The agency went as far as advising farmers to shift their planting calendars and switch to shorter cycle, drought-tolerant crop varieties. That is not a vague outlook. That is an agency telling its farmers to change what they plant because of what is coming. Australia. Below average rainfall outlooks across key agricultural zones. Australian wheat production forecast to fall by something like 19%. And Australian cattle were being sold off in record numbers, ranchers liquidating herds ahead of a dry forecast because they could see what was coming for the pasture. I want to pause on that last detail because it is the kind of thing that does not make headlines but tells you something true. When ranchers start selling herds ahead of a forecast, that is not panic. A herd takes years to build and a season to lose. Selling down early is a hard, expensive decision. The fact that it is happening at scale tells you that the people closest to the land are taking the El Niño signal seriously enough to act on it now. 3 continents, 3 agricultural systems, already changing behavior because of what the Pacific is doing. Now lay the pieces out one more time. The United States wheat belt, the cushion, drought hit and rated worse than last year. Global grain stocks, the buffer, drawn down. Corn carryover at more than a decade low. India, Indonesia and Australia, 3 regions square on the El Niño loss map, all already forecasting below normal rainfall, all already adjusting.
This is not a well-buffered system. Every single component that is supposed to provide resilience, the cushion, the buffer, the diversity of the loss map regions themselves, is already degraded before the official onset. The mechanism does not have to break down a healthy system. It has been handed one that is already coming apart at the seams it most needs to hold. Part 8. The hottest stage possible. Everything described so far, the loaded ocean, the synchronization mechanism, the stressed breadbaskets, is happening on top of the planet already running a fever. April 2026 was the joint third warmest April ever recorded. The global average surface air temperature for the month was 14.89 degrees Celsius. That was 0.52 degrees above the 1991 to 2020 average for April, and it was 1.43 degrees above the estimated pre-industrial level, the temperature of the planet before humans began burning fossil fuels at scale. 1.43 degrees above pre-industrial, for a single month, in what is supposed to be a relatively quiet part of the year. There is an international target written into climate agreements of holding long-term warming to 1.5 degrees above pre-industrial. That is the threshold that has been treated for years as the line we were trying not to cross. And here is a single month in what is supposed to be an ordinary year already pressing right up against that line, with the El Niño push still to come. The thing that was discussed for a decade as a future boundary is now the temperature of a recent month. The oceans are even more striking. April 2026 had the second highest sea surface temperatures ever recorded for the world's oceans outside the polar regions, and the Copernicus Climate Change Service reported record high sea surface temperatures across large parts of the tropical Pacific, the exact stretch of ocean where the El Niño is forming. The stage and the actor are the same water. March 2026 had already come in as the fourth warmest March on record at 1.48 degrees above pre-industrial. And when you take independent analyses that track the major temperature datasets together, 2026 is on course to land as roughly the second warmest year in the entire record, behind only 2024. The planet was already running near record warmth before the El Niño had even officially formed. Normally, El Niño is the thing that pushes a year to a record. The background trend warms the planet slowly, year by year, and then an El Niño gives it a sharp temporary push, and that pushed year sets the record. 2024, the current record holder, was an El Niño year, exactly the normal pattern doing what it normally does. What is strange about 2026 is the order of events. The planet is running at near record warmth first, on the strength of the background trend alone. The El Niño push has not even been delivered yet. So the question is not whether 2026 will be warm, it already is. The question is what happens to an already near record year when the El Niño finally lands its push on top of it. And here is where it connects straight back to the food story. A warmer ocean is not just a warmer number on a chart. The ocean is the engine room of the whole monsoon system. The monsoons that feed the loss map regions are driven by the temperature contrast between ocean and land, by the moisture the ocean gives up into the air. When the global ocean is running at the second highest temperature ever recorded, and the tropical Pacific specifically is setting records, the El Niño is not arriving onto a calm sea. It is arriving onto an ocean already running hot. That is the difference between the original 1877 machine and the version that could run in 2026. The heat does not replace the mechanism, it amplifies it. Same match, very different room. Part 9. The implications stated plainly. Let me bring you back to where we started. Most people heard the words El Niño watch this week and filed them as a weather story. A wet winter somewhere, a dry one somewhere else. Something for the reservoir managers and the ski resorts. Now you have everything you need to see why that is the wrong read. El Niño is the one force in the climate system that can synchronize crop failure across continents, override the independence the entire global food system assumes between its breadbaskets, and pull them down together on a single signal. That is not a fringe claim. That is what the 2019 study in Science Advances found when it tested 4 major climate modes, and only El Niño could force globally synchronous failure. 1877 is the proof that this is not theoretical. The mechanism is real. It has run at full power before. When it did, 50 million people or more died because the monsoon failed across India, China, and Brazil at the same time. The 2018 attribution study showed exactly how, the triple whammy, 3 oceans pulling together. The global food system, its insurance, its reserves, its trade models, is built on the assumption that this mechanism does not exist. And 2026 is walking into the event with the breadbaskets already stressed, the granaries already drawing down, and the planet already at record heat. That is the implication, the terrifying one no one is talking about. Not that El Niño is coming, everyone is saying that. The implication is that the world built its food security as though the one force that can break it does not exist. Now I have to do the most important thing in this entire video without any ambiguity. I am not telling you that 2026 is going to repeat 1877. A literal repeat of that death toll is not the probable outcome of this El Niño, and I want to be completely clear about why. The reasons are real and substantial. In 1877, there was no early warning. Today, there are thousands of instruments in the tropical Pacific feeding data in real time. The watch issued this week is itself proof the warning system works. In 1877, there was no meaningful relief apparatus. Today, however imperfect, that capacity exists. And the specific political structure that Davis argued turned drought into mass death, the forced integration of subsistence populations into colonial commodity markets with no protection, does not exist in the same form today. A major newspaper analysis in mid-May asked this exact question, whether a 2026 El Niño could match 1877. The careful answer it landed on is the right one. An El Niño rivaling 1877 as an ocean event is plausible. A humanitarian catastrophe on the 1877 scale is not the probable result. So the danger in 2026 is real, but it is different in kind. It is not a foregone death toll. It is a danger to food prices, to food security, and to supply stability. And it lands hardest, as these things always do, on the poorest, most import-dependent countries, the ones with no cushion of their own. Here is the realistic pathway. Modern grain markets are globally integrated and, as we saw, thinly buffered. A synchronized yield shock across several major exporters does not need to cause a famine to cause a price spike. It just needs to make the world short. And when wheat, rice, and maize spike in price, that price shock travels. It travels straight into the import-dependent countries that buy their calories on the world market. And historically, it has translated into food insecurity, hardship, and political instability, even in years when no single crop failed in the catastrophic total sense. The food price episodes of 27 to 28 and 2010 to 2011 are the reference class. Nobody starving in a field in the 1877 sense, but prices spiked and the consequences rippled across dozens of countries. That is the realistic shape of the 2026 risk. The 1877 mechanism expressing itself in the 21st century, not as a death toll, but as a price shock landing hardest on the people least able to absorb it. The grain still exists. It still moves. It just moves toward whoever can pay the new price and away from whoever cannot. That is the quiet, modern face of the mechanism. It does not look like a drought on the news. It looks like a line on a budget and a slow tightening in the places with the least slack to give. The synchrony does not have to kill the harvest everywhere. It only has to make the world short enough, all at once, that the price becomes the weapon. And there is a reason this lands on the poorest, hardest, every single time. It is not bad luck. It is structure. The countries most exposed are the ones that import the largest share of their staple calories, hold the thinnest reserves of their own, have the least fiscal room to subsidize food when the price jumps, and whose populations spend the highest fraction of their income on eating. Every one of those vulnerabilities compounds the others. That was true in 1877, and the modern version follows the same gradient, even though the mechanism at the top is just an ocean. The honest caveat, stated plainly, the uncertainty here is about timing and magnitude. It is not about the mechanism. Whether this El Niño peaks as strong or super, whether it bites hard or only moderately, that is genuinely unknown. Anyone who tells you otherwise is selling something. But whether El Niño can synchronize global crop failure, whether the mechanism is real, that is not a forecast. That is settled science. And 1877 already proved it with 50 million lives. The terrifying implication is not that history is about to repeat. History is not a tape that plays again. The implication is quieter. And in a way, it is worse. The modern world, with all its instruments and models and global trade, built its food security as if the 1877 mechanism does not exist. As if the breadbaskets really do roll their dice separately. As if the pillar holds. The science of the last decade has shown clearly, repeatedly, that the pillar is a belief and not a law, and that the one force that can knock it down is the exact force a watch was issued for this week. The reason nobody talks about it is almost banal when you think about it. It is not a cover-up. It is not a secret. It is just that the assumption is invisible precisely because it has worked most of the time for most of living memory. The breadbaskets mostly have failed independently, year to year, and the system has mostly absorbed those shocks, and so the assumption never had to be examined. It became part of the furniture. You do not notice the foundation of a house until something tests it. The independence assumption is the foundation. A super El Niño on the 1877 pattern is the test it was never designed to take. The watch is issued. The ocean is loaded with heat in the same class as the strongest events ever recorded. The breadbaskets are already stressed. The planet is at record warmth. The only thing genuinely unknown right now, the only piece still missing, is whether the atmosphere will finish what the ocean has already started. We are going to be watching that coupling all summer. Watching the monsoon forecasts, and the wheat ratings, and the grain stocks, and the slow conversation between the ocean and the sky. Because somewhere, in the next few months, the Pacific is going to decide whether 2026 is a story about a weather pattern or a story about the assumption the whole world forgot it was making.